So my name is Doug Bernhardt. I am a senior principal engineer with Dell Technologies, and I'm specifically focused on integration with Microsoft Data Platform in our mid-range storage products. I've been working with SQL Server well over 25 years now. So I guess at 25, I stopped counting number of years at that point, but long time. And I come from a very traditional background of SQL Server, running SQL Server on Windows. And so what I want to share with you today is a very interesting use case and really a pretty cool use case for PowerStore, and specifically PowerStore X with a Kubernetes data application, SQL Server 2019 big data clusters. So at this point, you're probably familiar based on all the earlier sessions with PowerStore, and you've heard about PowerStore X and its capabilities and what it can do. But a little bit of introduction here about this application, this workload of SQL Server 2019 big data clusters. So at the end of 2019, Microsoft introduced this new data platform product called Big Data Clusters, or BDC for short is what they call it. And really they set out to accomplish a couple of different things. So the first one was to try to connect all of the data where it sits within an enterprise. Traditional reporting and analytics solutions typically involve moving data around in these processes called ETL, or extract, transform, and load. And so these processes took time to develop. They take time to execute on a regular basis. So if you can leverage, being able to eliminate those for more real-time results and save investment in writing and maintaining all that, then it's a pretty attractive proposition. And so the goal was to be able to connect all these different data sources where they sit, whether the data is in relational databases like SQL or Oracle, different NoSQL data sources, such as files sitting on Hadoop. And then one of the other things that they introduced was this interesting idea of HDFS tiering. And so within the big data cluster, they added HDFS, and we'll take a look at this in a minute, but they also added the ability to connect to a remote HDFS data store. And so one of the things that's interesting about this from a Dell EMC portfolio standpoint is, we could actually leverage data that's sitting on PowerScale using OneFX to connect to this data, just as if it were sitting in a local cluster. So the other thing that they wanted to do with this product is allow users to also gain intelligence across this data using technologies that they know, such as SQL, but also using newer technologies such as Apache Spark, running scripts within Jupyter notebooks, and then being able to do all this under this single pane of glass management in a familiar tool with Azure Data Studio, which Azure Data Studio, if you're not up to speed on it, it was kind of the next evolution of SQL Server Management Studio that DBAs used for years and years. And then finally, to be able to put this in a cluster that was scalable right out of the box. So let me present an architecture picture here. And this is Microsoft's diagram. The URL here is at the bottom of right off the What Are Big Data Clusters site. But in essence, there's a lot going on here. But we have in the middle, we have this big data cluster application. And then at the bottom, our infrastructure, and then you can see how they have some external data sources on the side, and then up at the top, some different applications that would connect to it. So that's kind of the overall vision. Here at the bottom is really our infrastructure layer. And so in this case, in the use case that I'm talking about, we're going to deploy this entire infrastructure on top of PowerStore X to really try to simplify the experience of having to set all this up within a physical environment. And then in the middle here is the big data cluster application that would be deployed on top of all of this infrastructure. So a lot of components here, not going to go into it in great detail. But the main takeaway here is that, we've got a lot of stuff going on here. And somehow we need to deploy this on top of Kubernetes and in our infrastructure. So as you can kind of imagine, number of challenges here to set out to do this, right? So Kubernetes is a very new platform, especially to the traditional Microsoft data person who's maybe been running SQL Server, such as I was prior to this, for years and years and years. So they're coming from primarily Windows background. They're used to an deployment experience of running setup.exe, and this is very different. So in this case, with this big data cluster application, it only deploys on Kubernetes. And there's a handful of Kubernetes distributions that are supported today. If you're familiar with Kubernetes, you'll know that in the market, it keeps changing, but I think there's something like 40 or 50 different certified distributions of Kubernetes that you kind of have to weed through and choose from depending on what you're doing and what your preference is. So it's not exactly a trivial task to not only select that, but also to build this out. So in this deployment, like for big data cluster, you're looking at a minimum of 3 nodes to set that up because it's a clustered environment. You have to establish networking. You have to configure a control plane. So a lot to do there. In addition to that, there's kind of this whole, philosophical idea of within Kubernetes is it really a good idea to be running databases inside of containers, right? Container design from a purist standpoint is supposed to be ephemeral by design, meaning that you spin these things up and if they crash or they go away, then you just create a new one from scratch and you're really not too concerned with state. So that had to be overcome. And part of that is overcome by the work that's been done within the Kubernetes environment of introducing this concept of persistent storage. So while, to people that are unfamiliar with containers and Kubernetes, that sounds a little bit, strange, right? Like, what do you mean storage wouldn't be persistent? But from a container paradigm and a Kubernetes paradigm, by default, if you store data in a container and that container stops and is restarted, your data is gone. So Kubernetes introduced this idea of persistent storage, persistent volumes, and then there's a whole set of commands and APIs and things like that for dealing with it within Kubernetes to basically overcome that. So once you get past the Kubernetes hurdle, right, then you have this whole SQL BDC platform to deploy on top of it. So it's a completely new deployment experience because you're working on Kubernetes. A lot of the stuff is Linux based. We're deploying components in here in terms of Hadoop and Spark, Grafana, Kibana. So there's a whole lot of stuff basically in this BDC box. We're looking at approximately 22 pods to be deployed within Kubernetes, 46 containers within those, and then 26 of these persistent volumes, which actually translate to storage volumes that are dynamically created when you deploy this whole thing. So, the good news is there's still a familiar face within this cluster, and that is a SQL Server instance that gets deployed in here. So in the reference architecture I did, I used PowerStore X and PowerStore X apps on because I really wanted to try to simplify this deployment as much as I could, simplify this experience, and be able to give customers a quick on-ramp to getting up to speed and being able to stand this up and be able to start working with it and exploring it. So with PowerStore X, it brings a very simplified deployment experience from this perspective. It's a small, footprint. You get basically, the whole environment in a box with a hypervisor included. And it also gives us a convenient starting point.
So Doug, you're running Tanzu on PowerStore X to get the Kubernetes environment that you need to run this?
We're not running Tanzu. What we're doing is we're deploying a distribution of Kubernetes
in a VM.
Right, across VMs.
I got you.
Yep.
All right.
Yep. So being able to have the starting point, right, in a virtualized environment where we know what the networking layer is, we know what the hardware layer is, it just makes, things a lot easier. Being able to leverage technologies such as vVols for storage. So in addition to that, with PowerStore X, then we can also get, a wide range of performance and features. We can take advantage of the performance that we need for data applications because of all the reasons mentioned earlier for PowerStore X. But the main one, in this case being that our storage is close to compute and we have an appliance that's purpose-built for storage. We also get, rich data services with this that you don't get if you just kind of build this from bare metal and you build out your own Kubernetes cluster using JBOD or built-in drives. You have compression, deduplication, hardware-based, snapshots and all different kind of things. And then in addition to that, for a flexibility standpoint, then if we want to be able to do things with block volumes or whatever, then we can use those as well. And then finally, and I think one of the biggest points here is we're able to easily expand this PowerStore apps on cluster, right? So we can, as our Kubernetes cluster grows, we can expand our PowerStore apps on cluster. We can also size this up and size it down. So one of the things that was apparent very quickly is when you're getting up to speed on Kubernetes, when you're getting up to speed on newer applications, especially one like this that has a lot of different components, trying to get the sizing right is, especially the first time, is extremely difficult. So it's probably going to take, a couple iterations, especially depending on the workload that you're running on top of this cluster, to nail the sizing and get it exactly right. So within a virtualized environment, they're super easy to spin up, tear down, resize VMs. It really makes it much more practical than having to try to go and say, okay, I want to go add physical memory to 3, 4, 5, 10, 20 physical nodes, right? So what we did is we put together a very step-by-step white paper and reference architecture for this environment that's built on top of PowerStore X. In that white paper, we also go into some detail of kind of the differences of building out physical versus virtual Kubernetes clusters. Obviously you could still build a physical cluster and you could have that backed by, PowerStore T storage as well. So it kind of talks about some of the differences in there. And then also goes into a little bit more detail, getting into the weeds from a Kubernetes standpoint on the CSI driver and the storage layer and what the trade-offs there of using, say, the vSphere CSI, which we're leveraging in this example, versus a Dell EMC CSI driver. And within this paper, then we go into, there's two very specific deployment examples. So I walk through a step-by-step deployment example of how you would deploy this BDC environment from start to finish on PowerStore X using a vanilla Kubernetes distribution, and leveraging Ansible and KubeSpray, which is a series of Ansible playbooks that were written and developed for Kubernetes deployment. And then finally, for customers who want a very, fully supported from start to finish environment, I also go through an example of deploying this environment on OpenShift as well. So OpenShift has emerged from Red Hat as kind of one of the leading Kubernetes distributions for enterprises that are either a Linux RHEL shop, or they do want that full end-to-end enterprise support experience.
So Doug, I don't know if you're going to talk about this, but why would you choose vSphere CSI versus Dell EMC CSI?
Yeah, so that's a pretty good question. In general, if you want more specific support for, say, your storage features, if you want to take advantage of, say, like hardware-based snapshots, or one of the other things that we do is we allow multiple storage appliances to be connected to the same Kubernetes cluster with our storage. There's also other advanced things such as like being able to specify which the storage is only presented to specific nodes or available to specific nodes. So because vSphere and VMware works the way it does and it's virtualized, sometimes the features that are available at the hardware layer, it's a kind of a set of
more generic capabilities kind of thing.
Exactly. Yeah. So if you really want to get more hardcore storage control and things like that, then that's where you would look at our CSI driver.
All right, thanks.
Yep. So in addition to the white paper that we did on big data clusters on PowerStore X, if you go out to dell.com/storage resources, we have a ton of papers out there for not only PowerStore, but also all the different Dell EMC storage products. So you would go to dell.com/storage resources and then navigate to PowerStore and SQL Server under that. There's stuff on this Kubernetes solution. There's also stuff for PowerStore on just general SQL Server best practices. A lot of other stuff on Linux and containers as well.
Somewhere earlier you mentioned that there were like 22 pods, I think, in the configuration for the big data cluster. Do those end up being separate VMs? Is that how it would play out?
No. So what happens is, I'll try to describe this. So you have a VM that's going to run as a node within Kubernetes. Okay.
Like a worker node or something like that.
Yep, exactly. And then on a worker node can run, 1 to n number of pods. And then the containers then run within a pod. So a pod is kind of like a shared mechanism for communication for containers.
I got you.